This video is for grade 9 mathematics. Hello there and welcome back. I'm so glad that you're here to join us in the next lesson. But before we start, friendly reminders. Do not forget your paper and pen for your solutions later on. And do not hesitate to pause and play this video when the need arises. You can even repeat the video for mastery purposes. So let's begin. I will guide you in the first module, the first quarter of our subject mathematics under the general topic quadratic equation. I am your math teacher. I am Mrs. Rowena Olofernes. In this video presentation, we are currently tackling about lesson number 2 about solving quadratic equation by extracting square root and quotient rule. What do you need to know? At the end of the lesson, you are expected to determine the factors of a number that is not a perfect square and solve quadratic equation by extracting square root. So we have two main goals in this lesson or in this video presentation. What's in? Study the examples that will be flashed on your screen and how these equations have been transformed into its standard form, and try to observe the different solutions for each item. Looking at example number 1, we are given 5 minus x to the quantity or multiplied to the quantity of x minus 3 is equal to 0. This would be our solution. Look at my laser pointer to follow. This would now be 5 minus x squared plus 3x is equal to 0 after applying distributive property of equality. The next line will be negative x squared plus 3x plus 5. So we are now rearranging our polynomial in decreasing order for our exponent. So we have here 2 followed by the linear term and then our constant to follow the standard form of our quadratic equation as what we have discussed in our lesson number 1. So our quadratic equation is now x squared minus 3x minus 5 is equal to 0. Observe carefully that the line before that is still negative x squared plus 3x plus 5 is equal to 0. We multiply both sides of the equation by negative 1, so changing the signs from negative to positive, here from positive 3 to negative 3, and here positive 5 to negative 5. Since 0 times negative 1 is still 0, that's why on the right side of our quadratic equation, we still have here 0. So basing on this, our terms would be this. X squared for our quadratic term, negative 3x for our linear term, and finally negative 5 for our constant term. So that's how we get the answer. Were you able to follow? That sounds great. Let's move on. Let's look at our second example. So let's look at example number 2. I'll be using my laser pointer to point our given. You're given 3x multiplied to the quantity of x plus 2 minus 15x is equal to 0. This would be our solution. Similar to example number 1, we'll be using distributive property right here, and then we are going to combine like terms. Thus, our result is 3x squared minus 9x is equal to 0. We've got negative 9x because this is now the combination or the sum of positive 6x and negative 15x. Now, based on this quadratic equation, we have here these terms. 3x squared will now be our quadratic term, negative 9x is our linear term, and here we have 0 for our constant term. Let's look at example number 3. This time, you're given 5x times the quantity of x minus 4 plus 7x is equal to 25 minus 13x. So again, if you see this one, that means you can apply distributive property of equality. So let's do that. We have here 5x multiplied to x, so we have 5x squared. After that, we will multiply 5x to negative 4, so we'll have negative 20x. Copy plus 7x, and then copy the equal sign, and copy the remaining terms in the right side of our equation. That's 25 minus 13x. The next line will now be based on this part right here. So where did we get this? Now what we did here is we transferred 25 minus 13x, everything or all the terms in the left side of our equation. To do that, we need to apply the different properties of equality. In this example, specifically, we used addition property of equality. So that means, students, we are adding here negative 25 in both left and right side. Same with positive 13 to eliminate 25 and 13 or negative 13 on the right side and make it 0. That's why we now have positive 13 and negative 25. So we now have here this line, 5x squared minus 13x plus 13x minus 25 is equal to 0. Where did we get negative 13x? This is the result after adding negative 20x and 7x. Okay, so far so good? Good. So we now have here 5x squared minus 25. Since negative 13x plus positive 13, or I mean plus 13x, will now be changed to 0, or the result will be 0. Thus, 0 minus 25 will give you negative 25. So this is now our quadratic equation. So based on this, our terms are as follows. 5x squared, that's our quadratic term. 0x, that will be our linear term. And negative 25 as our constant term. Do you understand? Let's look at the 3 examples. So we have examples 1, 2, and 3. Try to observe the solutions and compare. Do we have or do we follow the same solution for all the given? You may pause this video to compare the 3 examples. Now what's new? Looking at our 3 examples and focusing on the quadratic equations, these 2 equations are incomplete because it only contains the quadratic term ax squared and it's being paired with the linear term or a constant term c. So this one is being paired with a linear term and this example is being paired with the constant term. Now, all of these examples are still quadratic equation. Now, how do we solve for its roots? How do we solve for the specific value or the solution of x in these quadratic equations? What is it? Looking back at our example, since the first example here is already in standard form, we do have a different method for that. Now, for this video presentation, let's focus on the second and the third example right here. So how do we solve something like this? We can use the square root property. Yes, you've heard it right. It's the square root property. Now, how about the third example? You can use the quotient rule. Correct. You will use the quotient rule. Now, let's focus first on the first method. That is the square root property. Now, this would be the example. And when we say square root property, that would state that if your x squared or if x squared is equal to k, and k here is a non-negative integer, then x will be equal to the roots of the k. That means it's positive and negative square root of k. I repeat, if this will be your given, x squared is equal to k, and k is a non-negative integer, then the value of your x will now be the roots of the k. That means it's both positive and negative square root of k. Clear? Great. So how do we solve something like this? 5x squared minus 25 is equal to 0. As mentioned, we will be using square root property. Now, for square root property, there are things that we need to consider. We can only apply it if the given quadratic equation has this, a quadratic term, and this, constant. So if you have the two terms, the quadratic term and the constant term, then that means there's no problem at all. You can simply use the square root property to solve for the roots of x or to solve for the solution for this quadratic equation. Let's try to look at this. For example, ax squared plus minus c to represent our values of a and c as real numbers, wherein a is not equal to 0. So let's say that is our quadratic equation. Our next step is using the square root property. This is, take note, we are using the square root property. So to do that, we need to consider that there's still a numerical coefficient besides your x squared. So we need to eliminate that by using multiplication property of equality. So we will divide both sides, the left and the right side, by 1 over a. Okay, good. Now the next step here is, since we are left with x squared, we need to find the value of x alone. So x alone. Are you following? Now to do that, we need to get the roots, or we need to get the square root in both the left side and the right side to get the value of x. So that will be our next step. Okay, so this time, our answer is equal to plus and minus square root of the quotient of c and a. Again, where a and c are real numbers and your a is not equal to 0. Now let's try to look at some examples. Let's have example number 1. Let's confirm. We do have here the correct. That's the quadratic term. And your second term is a constant. So it's a check and a check. So that means we can use the square root property. To solve for that, let's proceed to the next step. Here, since there is no numerical coefficient greater than 1 besides your x squared, that means you can proceed to the next step. That is, you're going to add in both sides 64. So that you'll have your x squared is equal to positive 64. Now, why did we have the square root here? Remember, every time we have the square for our variable, and to eliminate that, we need to, because our main objective is only to find the value of x. So to do that, we will get the square root in the left and the right side. Good. Now, next step here is, since this is a perfect square, 64 is a perfect square, then we have here an answer. So the answer here is x, or our roots, is equal to positive and negative 8. Therefore, the roots are negative 8 and positive 8. Now, let's try to look at the next example. Here, you're given 5x squared minus 40 is equal to 0. Let's check. The first one here is a quadratic term. Check. Second term here is good. That's a constant. Therefore, we can use square root property for this example, or for this quadratic equation. So the next step is, we are going to add 40 to both sides of our equation. So you'll have 5x squared is equal to 40. And after that, what you need to do next is, since our x squared, or the variable here with the highest degree of 2, or our quadratic term, has a numerical coefficient of 5, so we need to eliminate that 5. So we are going to apply multiplication property of equality by multiplying 1 over 5 to both sides of our equation. So that's why we have this one. 5x squared over 5 is equal to 40 divided by 5. Do you get the point? Great. So, we now have x squared is equal to 8, right? So, we need to find the value of x alone. So, it's still in x squared. So, we are going to use, or we are going to get the roots. So, let's get the square root, or apply square root in the left and right side of our equation. So, our answer is positive and negative 2 square root of 2. Now, how did we come up with this? 8 has factors 4 and 2, and 4 is a perfect square. So, getting the roots of 4, that is 2, right? The square root of 4 is 2. So, we still have inside the radical sign the remaining number, that is 2. So, our answer is positive negative 2 square root of 2. So, we have two answers. The roots are negative 2 square root of 2, and the other one is positive 2 square root of 2. Do you understand? Brilliant. Let's move on to our next example. In here, Our example is quantity of x plus 2 squared is equal to 9. Now, how do we solve for this? We need to check if we have a quadratic term and a constant to make sure that we can use our, square root property to solve for the roots and the solution of x in this quadratic equation. Now here, x plus 2, our binomial, is raised to the power of 2. That means if we are going to consider this as one term, then that means this would be our quadratic term. And 9 would serve as our constant. Do you understand? Okay, so what will be our next step? Since we already have here x plus 2 squared as our quadratic term, and then 9 is our constant. So the next step is, we are going to eliminate the squared right here. So we are going to apply square roots in both the left and the right side of our equation. So let's see. That's it. We are going to apply square roots. So here, the next answer is, that's it. We now eliminated our square roots and at the same time the squares. So we are left with x plus 2 is equal to the roots of 9, that will be plus and minus 3. Do you understand? But in the left side of our equation, it's still not yet final. We still have here positive 2 and we are looking only for the value of x. So what we need to do is we will apply addition property of equality in both left and right side. We are going to add negative 2 to eliminate positive 2 here. Do you understand? So let's see the next step. There. So we have x is equal to negative 2 plus minus 3. So here, we need to use the first one, which is plus 3. That's negative 2 plus 3, like this. And solve for that. The answer is 1. So that will be our first root. The second one is making use of negative 2 minus 3. That gives you a 5, a negative 5. So our roots are negative 5 and positive 1. So that's how you solve this example. Were you able to follow? So the steps here is we apply the square root on the first line. The second step is, we've eliminated the squared already. So we copied the given. X plus 2 is equal to, here, we extracted the roots of 9 will give us positive and negative 3. So since we are only looking for x, then we are going to use addition property of equality by adding negative 2 to the left side to eliminate this positive 2. So we are left with x. And adding negative 2 to the right side, that's why we have here negative 2 and we copied plus minus 3. So here we have two roots. Since negative 2 plus 3 gives us 1, that will be our first root. The second root is negative 2 minus 3, which gives us negative 5. Do you understand? Brilliant. So for our next example, this will be our last example for this property or the square root property. So look at this. We have 4x squared minus 256. Let's check if we have the components. The first one is, what is this? Good. This is a quadratic term. Check. This is a constant term. So we are having two terms and that means we can use the square root property. So what would be our next step? Here. So the first thing that we need to do is make sure that this number or the constant will be placed in the right side of our equation. To do that, make sure that you are going to apply addition property of equality in both sides of the equation. So we have negative 256 added to 256, or we are going to add 256 to eliminate this. So we have positive 256 on the right side of our equation like this. Now, why did we use a square root? We use a square root because we still have here x squared. We still have the squared. And since 4 is a perfect square, then we can square root or we can get the square root or we can apply the square root in this term. So our answer is now, that would be 2x is equal to plus and minus 16. 16 because this is also a perfect square. The answer is 16. We still have 2 besides our x, and we are only looking for the value of x. So what would be our next step then? Great. We are going to, correct, divide both sides by 2 so that we are left with x in the left side of our equation. So 16 divided by 2 would give us an 8. So the final answer is x is equal to plus and minus 8. So our roots are -8 and +8. So that's how we solve this problem. So again, our first step is, yes, making sure that on the left side we have our our quadratic term, and on the right side we have our constant. So to do that, what property did we apply? That's it. That's addition property of equality. Right after that, yes, we extracted the root since this term is already a perfect square similar to the right side. Great. Now, our answer here is 2x. That's equal to positive and negative 16. How did we come up with an 8? Right. We divided both sides by 2. But actually, that is using multiplication property of equality. So we multiplied both sides by 1/2. And 16 times 1/2 is similar to 16 divided by 2. That's why we have 8 as our root. So we have 2 roots. We have positive and negative 8. Do you understand? Well, that's fantastic. How about for the second method? This method is making use of the quotient rule for the loss of exponent. So for example, we have here x to the power of m over x to the power of n. So suppose you have this. It will be equal to the variable x raised to the power of the difference between the numerator's exponent and the denominator's exponent. So that will be m minus n. Again, where m and n are positive integers and m is greater than n. So this was our example earlier. So when can we apply quotient rule? When we have a quadratic term like this and we have like this. That's your linear term. So if we have a quadratic term and a linear term, then that means we can use this method in getting the roots of our quadratic equation. So let's try to see the rule. For example, you have ax squared plus minus bx is equal to 0. Here, a and b are integers such that a is not equal to 0. Our next step here is, yes, similar to the previous examples, we make sure that on the left side of our equation, we have our quadratic term, and on the right side of our equation, we have the remaining term, and in this case, it's your linear term. Now, why do we have here ax in our denominator? So that will be our third step. So here, what we did is, yes, we eliminated ax because we are only looking for x. Same with the right side, divide it by ax. So here, we are left with x, that's equal to plus and minus b over a, because we already canceled out x. So this would be our final answer. So our roots will be positive b over a, and the other one is negative b over a. So this one is making use of the quotient rule, since the exponent in the numerator is 1, minus the exponent in the denominator is also 1. So 1 minus 1 is 0. Any number raised to the power of 0 is equal to 1. That's why you have only b over a here. Let's try to see some examples. Example number 1. Let's try to see the first example under quotient rule. So you are given 5x squared is equal to 125x. So let's see if we have here the following. If we have the quadratic term, this one is our quadratic term, and on the right side of our equation will be our linear term. Right? Good. So how do we solve for the roots of this quadratic equation? So we need to eliminate 5x so that on the left side of our equation, we are going to have only the only the variable x. So again, we are going to eliminate 5x. So to do that, we are going to multiply both sides by 1 over 5x. So here, we're going to divide 1 over 5. Same with the right side, divide it by 1 over 5. Like this. 1 over 5x. Take note, 1 over 5x. So here, we divided both sides by 1 over 5x. So it's similar to dividing both sides by 5x. So we have eliminated already 5x. And on the left side, we will be left with x. Why? Because we apply quotient rule. Here, our exponent is 2. And in the denominator, our exponent is 1. So we have eliminated 5. So to do that, allow me to use my pen. So we have here like x. And we already have 2 in the numerator. Subtract it to the exponent in the denominator. So that will be x raised to the power of 2 minus 1. That will give you x raised to the power of 1 or simply x. So that's how you do, yes, the quotient rule. Let's continue with the next step. Here, our answer is equal to 25. Why? We already have canceled x because they do have the same exponent, and 125 divided by 5 will give you 25. So the value of our x is equal to 25. Therefore, the solution of x in this quadratic equation is 1. That is one answer, that is 25. The root is 25. Let's look at the second example. You are given 4x squared minus 4x is equal to 32. Now, what do you think? Is this a quadratic equation with a quadratic term and a linear term? Observe carefully. Yes, you do have here your quadratic term, correct? But you have here two terms. That would be your linear term. At the same time, having the same variable, this is still considered as part of your linear term. And you don't have a constant. So since this quadratic equation has or have this quadratic term and also your linear term, it qualifies in using the quotient rule to extract its roots or to get its roots. So the next step will be, yes, we transferred negative 4x to the right side of our equation. To do that, we need to consider that we are going to follow and use the different properties of equality. So here, what we did, allow me to use my pen. What we did is to eliminate negative 4x. We added 4x here on the left side. At the same time, sorry for that handwriting. At the same time, take note we added. We use addition property of equality. On the right side as well, we added, yes, we added the same value, that's 4x. There. So we have added 4x to the left side, and we've added 4x to the right side. So since 4x minus 4x would give us a 0, so we are left with 4x squared. That's why you have it here, 4x squared. And on the right side, you have 32x plus 4x, like this. That's why we come up with that step. Do you understand? Good. Allow me to erase and continue with our next step. So here, what we did is we added the right side of our equation. We have 32 plus 4x will give us 36x. Now, where did we come up with this 4x? Remember, since we are using our quotient rule, we can use that law or we can use that rule from the law of exponents to solve for the value of x. So here, we can eliminate 4 by dividing it by 4. But take note, the property here is multiplication property of equality. Same here. 4, we are using 4. Let me erase that, just to clarify. So again, the main purpose of that is to eliminate this 4, at the same time to eliminate 1x. I mean 1 variable x, since we do have here second degree for x. So that will be 4x in the denominator because it's similar to applying our multiplication property of equality. Allow me to erase. So here, we multiply this by 1 over 4x. Like this. Same with the other side, we multiplied it by 1 over 4x. Same. So that's why, if you're going to multiply 1 by 4x squared, that will give you 4x squared. So the denominator will now be 4x. I am explaining how we come up with our 4x in the denominator because we applied multiplication property of equality. Are we good with that? Allow me to erase. So since we already have here 4x squared over 4x, can cancel 4, and we are left with x is equal to, now we have x divided by x that can be cancelled out. So we are having 36 divided by 4. That will give you, let's confirm, that will give you a 9. So I'll delete my handwriting. There you go. So our root will now be a 9. So the root of this quadratic equation is a 9. Moving on, let's try to see this example. We have 3x squared plus 8x is equal to 35x. Similar to example number 2, we have here our linear term, 8x and 35x. So this follows, yes, we have here a quadratic term and a linear term. Thus, we can use the quotient rule to get the solution or to get the roots. So here, we are going to apply what rule? Addition, what property rather? Addition property of equality. So we are going to add, yes, we are going to add a negative 8x. I hope you can, yes, that's negative 8x. There you go. And same with the right side, we are going to add negative 8x. So I'm going to enclose that in a quantity later on after I'm done writing x. There you go. I hope you understand that writing. So we added negative 8x to the left side, and same with the other side, we've added negative 8. That's why we come up with this. Negative 8x plus 8x will give you a 0, so you're left with 3x squared. And on the right side, you still have 35x and negative 8x. That's why you have this on the right side. Is that clear? Allow me to erase to clean up our screen. There. So the next step is, using our quotient rule, same with our previous examples, we are going to multiply both sides by 1 over 3x. Good. To eliminate the numerical coefficient, this one, eliminate the numerical coefficient of our variable. So we still have 3, and we need to eliminate one variable of x. So we are going to multiply both sides by 1 over 3x. Thus, we have like this. 3x squared over 3x is equal to 27x over 3x. Were you able to follow? Wonderful. So our answer here is, yes, we canceled 3 and 1 variable x. So we are left with 1x here, one variable for x. And then on the right side, we have canceled x. 27 over 3 will give you a 9. So in this quadratic equation, the root is 9. So far, so good. Now let's have our last example under quotient rule. Try to see the screen. Now, let's try to answer. Yes, applying the addition property of equality similar to examples 2 and 3. So we added both sides to both sides of our equation, positive 4b. Here, positive 4b, and we added positive 4v. So this would now be our next line. After that, we are going to combine like terms. So that will give you 2b squared is equal to 20b. like this. But we already have in the denominator 2b to eliminate our numerical coefficient and one variable b to only have b on the left side of our equation, because that is our main goal, to find the value of b. So again, we've used multiplication property of equality for that. We divided in the both sides, in the left and the right side rather, 1 over 2b. So our answer for b is 10. Because 20 divided by 2 right here will give you a 10, since we've canceled already letter B. So the root of this equation is 10. That's how you solve quadratic equations using the quotient rule. What's more, I prepared here 2 sets of questions for you to work on and for you to assess your learning based on our discussion about lesson number 2. So we have letter A. You are going to solve for the roots of the following quadratic equations using the square root property. And you're going to show your solutions, and do not forget to encircle the final answer. So we have here 5 items for this. And we have the second set. Solve the following equations using quotient rule. Show your complete solution. So we have 5 items again for this set. So again, we have 2 sets using square root property, and we also have using the quotient rule. Now you may pause this video for you to copy on the different items, or in the 5 items for A and the separate 5 items for letter B. And if you want to go back to the portion of our explanation with examples, then go ahead. No worries. Just take your time until you've mastered this lesson. You're still given ample time. Again, take your time, revisit, review that portion of that video for you to master that lesson. Are we good? Now, if you're done with this, do not forget to submit your paper with the complete solution on the agreed date. And finally, what you need to remember. So we have 2 very important points before we end our lesson. So the first one here is, what is it? Remember, for square root property, if x squared is equal to k, and k is a non-negative integer, then x will be equal to the roots of k. That will be positive and negative square root of k. And it has here a quadratic term, and this one is, yes, that will be the constant. So if it follows this, then you can use the square root property. Okay? Now the second point that you need to remember is for the quotient rule. Allow me to click on this for this quotient rule. So if x to the power of m is divided by x to the power of n, that will give you x to the power of m minus n, where your m and n are positive integers, and m is greater than n. So in this case, when your quadratic equation has a quadratic term, and this one is your linear term, then you can use the quotient rule to get the roots. Are we clear with that? So those are the 2 important or the essential points that you need to remember for today's lesson. That's it. You have successfully completed the second lesson of Module 1. Congratulations, and see you in the next lesson.